So there is a poll.csv file which contains polls which are basically trying to determine who is going to win an election between Ed Orgeron, the LSU coach, and Nick Saban, the Alabama coach. It's all hypothetical. It contains a vote of 1,000 people, and you're going to see what's exactly in the file from this code. So we start out importing the required packages. Nothing new here. Many of these are not going to be used. We're just importing it. So at this point, we load the poll.csv file, which I already put up on the GitHub page for this course. So it's pandas read_csv function. It reads this file and puts it into this data frame. We can show some of the information. You see there is just one column containing 1,000 values. We can see what those values are using the data frame.head function. It shows you the first 5 entries or items in the data frame, and that's the entry. So it's just either of Saban or Orgeron. So if it's Saban, it means this candidate is voting Saban. This is saying he will vote Orgeron, and this is saying he will vote Saban. So that's all you have in this file, 1,000 of those. And you can count how many people are saying they will vote for Saban and how many are saying they will vote for Ed Orgeron using this function. So by default, if you go in with false, it's going to go into that column, which is this, and count how many votes will go to Saban and how many will go to Orgeron. And it shows that here after running as 511. So there are 511 occurrences of Saban in this column, and there are 489 occurrences of Orgeron. So you can convert that to percentages by dividing by the total number of people, which is 1,000. And that's what you get when you use the argument normalize equals true. So I run it now and you see 51.1%. It's saying they will vote for Saban, and 48.9 are saying or indicating they will vote for Orgeron. Again, this is just a poll before the actual election. And I'll leave it up to you to read this. We already discussed this in class. And what we're moving on to do next is to perform a computer simulation to figure out the conclusion we can make from this data set. So I mentioned that we can't just jump into a conclusion to say this poll indicates Saban will win the election, because that will be a premature conclusion. We need to do some statistical tests to figure out the confidence in the conclusion that Nick Saban will win. And we're using computer simulation for that. We're going to simulate 1,000 of these kinds of polls using Nick Saban's win percentage, which is 51.1. So we're creating random numbers between 0 and 1, and anyone that's less than 51.1%, which is Nick Saban's winning percentage, will be voting for Nick Saban. And the numbers greater than that will correspond to voting Orgeron. So we use the numpy's where function to do that automatically. And it's generating random numbers, compare it to 51.1%. If it's less than 51.1%, then it's voting Saban. Otherwise, it's voting Orgeron. We create a function, right? Def sample. And it takes 2 arguments. First argument is the win percentage for Saban, which is 51.1. And the second argument It's the number of realizations. How many votes do you want to create? The original length was 1,000, so we choose to create 1,000 votes. This is totally optional. You could have gone in with this, and you will have to provide two arguments to the sample function. When you do this, it's optional to provide the second argument. So this is the default value for the second argument, n. And we use that here in this function. First argument is what? Sebann's win percentage. Second argument, which is optional, 1,000. So what you get here will be Sebann or Orgeron. And we can run these with Control Enter, Control Enter, Control Enter, and we're looking at the first 5 entries of this, and it's just Orgeron or Sebann. This is all random using Sebann's true win percentage of 51.1, and we want to see what will this win percentage be. So do the same thing we did on the original poll file. This result is different from this original poll file, right? This is all computer generated. And when you use the same function to count and look at the probabilities, Nick Saban is still winning, right? Because it's more than 50%. What if you generate another sample? Changes 50.1, it wins marginally, right? Based on that sample. Another sample, still winning marginally. I'm just running it a couple times. Is this running? Yes. 51% is still winning. But if you run it long enough, you will realize sometimes Orgeron actually wins. Oh, okay. Actually, in this case, Orgeron is winning, right? With a percentage of 51.1, so it's kind of reversed. Even though the original poll had Nick Saban winning. That's already telling you there is uncertainty in the conclusion that Nick Saban will win from just looking at 1,000 samples. And this is because your sample may not necessarily represent the true population, and that's the sampling variability we talked about in class. So if we come down here again, this is that realization where Orgeron is actually winning, even though you went in with 51.1 for Nick Saban. So what we're doing here is to use Python to generate 1,000 of these kind of realization. This is just one, right? So we generate 1,000, and we want to figure out the confidence in the conclusion that Nick Saban will win the election. So that's all this is. We're using that same sample function here. We don't provide the second argument, so it's 1,000. We use the value count so that it counts it and gives you this kind of result for each one of the realizations, and that's why we have this 4 here. Again, you probably remember this is list comprehension in Python. So for I in range 0 to 999, right? You never really get to 1,000. So it's going to generate 1,000 of these kinds of results. All of them are totally computer simulated. And when you use the head function, you can see what you generate. So one realization, Nick Saban has 50.5%, here 51, here Orgeron is winning. And you now have 1,000 of these kinds of results. And what we can do is to use our knowledge of normal probability distribution or Gaussian distribution. I talked about this in class, but the summary is we already know if you're within one standard deviation to the left or to the right from a normal distribution, 68% of the data will lie in that interval. 95% of your data will lie within plus or minus 2 standard deviation. and 99.7% of your data will lie within plus or minus 3 standard deviation. So since we're interested in 95 percentile confidence interval, 95% confidence interval, it means you're going to be left with just 5% outside of that interval. So you can break that 5% into two. So there is 2.5% on the left side of your interval, and there is another 2.5 on the right side. So basically, you need to find the 2.5% of your data and the 97.5 percentile of your data. And that will give you the maximum and minimum realization for that distribution. And that's what we're going to show shortly. So if you didn't get all of that, you'll get it here clearly. I tried to explain it in words, but here we look at the histogram, right? We learned how to plot histograms on topic 6. This is what the histogram looks like for Saban winning. So Saban's win percentage could be as low as 46%, which actually means he's losing. And it could be as high as 56. The mean generally will tend to the true mean, which was 51.1%. And that's the case here. So the fact that his win percentage can be as low as 46% already tells you that that poll is inconclusive. So he could either lose or win, is what this is saying. And that's what we have achieved by performing computer simulation. So here we're going to draw the lines corresponding to the 2.5% percentile, which I talked about before, and the 97.5 percentile. So between 2.5 percentile and 97.5 percentile, what you have is 95%. And that's what is in between these 2 points. So this is at 2.5 percentile, and this is at 97.5 percentile. So anytime you have this kind of stuff, you're saying 95 of your data lie within here. So there is 95% confidence that Nick Saban's winning percentage will be between 48 and 54.2. That's how you interpret this stuff. The point estimate will be the midpoint here, which is at the 50th percentile, and it's 51.1. And there is a plus or minus 51.1 minus 8, minus 4 point, sorry, 51.1 minus 48, which is 3%. So the point estimate is 51% with a plus or minus of 3%. That's how this is interpreted, and I leave it up to you to read through this.